Hi guys, we have been having some technical glitches. I hope we will be able to move on with what we have. So I'm not sure whether this is enough. I'm not sure whether there's someone who's online who can see whether the page is clear enough. Okay. So we will have to work with what we have. So we thought we were going to use the laptop and kind of take videos from there. That is usually what I do in my other lessons. But somehow I don't know how and why that I couldn't take a live video for using my laptop for the lesson. I guess we will just have to work with what we have and please bear with me and let's see what we can do and how far we can go with this. So we will be looking at analytical geometry. So analytical geometry is one of the interesting topics in grade 12 and it's been a while since I was in that grade, so I just want to make it clear that I'm also not a teacher, so there are some insights which teachers would have which I might not have, but I work with these things every day, so that's why I think perhaps we can succeed in trying to explain the ideas which underpin this concept of analytical geometry. And I think I must say that if you haven't seen my trigonometry lessons, it will be helpful if you try to access the lessons, because that's where we started with introducing right-angled triangles, Pythagoras and all that. So this is what we have, and where does analytical geometry come from? So this is geometry. And most of the ideas were originally documented by the Greeks. So these ideas were around the 1630s, in particular the idea around analytical geometry. And it was a guy by Descartes, a Greek philosopher, and de Fermat. So if you go on with your mathematics to a high level, you will meet these names, but I'm sure you've already met Descartes, because here I've drawn a triangle in a Cartesian plane. So Cartesian, we call this Cartesian coordinates. So you can see Cartesian is from Descartes, and and we know that with each and every triangle A, B, C, we know that Pythagoras has already informed us. And as I said, if you haven't seen this, please go to my wall and find the trigonometry lessons. They're very basic and simple. But for a triangle, for a right angle triangle, we know that Pythagoras has told us that the square of the hypotenuse, which is AB squared, should be given as the square of the adjacent and the hypotenuse. Right? So this is Pythagoras. Right? So guys, please do comment and tell me whether you can see my workings here, and if you can hear my voice, right? It's the first time I'm doing this in this fashion, so we are just trying to make this work. So that's Pythagoras, right? And of course, here you can get the expression for AB without the square, which is going to be just the square root of AC squared plus BC squared. Right? So this is what we know. I'm assuming my audience is predominantly grade 12. So this is what you should know already from Pythagoras. This is just simple arithmetic. You are getting rid of the square root of the square by taking the square root, right? And if I mean you observe, you will see that AC squared. How can we express this line segment AC, the distance from A to C? I mean, and you can see that this is on the horizontal axis. So, I mean, if you want that distance, you should say that point minus that point, right? So AC should be x2 minus x1 all squared, because AC is squared here anyway, right? So, and same logic goes for BC squared. And what is BC? BC is that line segment, right? And how can you express the length of that line segment? The point there is y2 and the point here is y1, the y coordinate, because you can see that this is this is horizontal and this is vertical. So you can see that the only coordinate that will play a role here will be y, right? So from there to there, we can simply say y2 minus y1 all squared, right? So that's what we have. So I mean, analytical geometry is about triangles, circles, mainly distances between points. Distances between points in triangles, trying to see how do tangents or lines that cut circles or touch the circle at one point behave, and how can we describe them using mathematics, right? So this is the first important result we have. I mean, this is a very important result. I will call it 1. And what is this result saying? This result is saying that the line segment AB, the length of the line segment AB, or if you like, the distance between A and B, can be given as the square root, can you see, of x2 minus x1 all squared plus y2 minus y1 all squared. So this is just Pythagoras phrased differently. So this equation will be very important in analytical geometry, because this is the equation that will determine the line segments, the distances between points. And in geometry, that's what we are interested in, because in geometry we are speaking about spatial distances. I mean, can we describe them? Can we find relationships between angles and lines? So that's the primary intention. So I don't know. You've just heard the call coming in. I think that is Tobani. Or one of the organizers. Is there something wrong, guys? Anyway, I will go on unless they call again, and then you will excuse me when I take their call, because it might be something about the video or something. I don't know. They are the organizers. So but this is the first important result for distances between points and lengths, right? So you can interpret this in two ways. This is a length, right, of a line segment, or because if it's a length of a line segment, at least it should have 2 points. That's the definition of a line. Definition of a line is that there should be at least 2 points and something that connects them in between. So here you have the distance between 2 points and the length of the line segment. So this is the practical meaning of this equation. Okay? I hope that is clear. Okay, so let's just move right along. So what else is important? So what have we done thus far? We have defined the length of a line segment, right? And yeah, so this is the distance between 2 points. So let's move right along. So a closely related concept is the concept of gradient. Gradient. So this will be very important. So this will be very important now because we, of course, we are dealing with lines. We are dealing with like spatial distances, and of course, it's nice when you have things being flat and all nice, but sometimes you do have slopes, and by slope we mean you have a line which is monotonically increasing, or which is a monotonic function. And a monotonic function, it's either a function that is constantly increasing or decreasing, right? And if that's the case and it's a straight line, then it will have a gradient. It's like driving on a steep hill. I mean, if you are those who amongst those who got their licenses the legal way, there should be, in part of the test, there should be where they take you to a steep. And what distinguishes a steep from a flat plane or a flat road is the gradient between the two surfaces. So the gradient is how steep is your surface or your line in this case, because we are speaking about a line. And how do you express that? So I will just write it as m. Typically, conventionally, the symbol used to denote gradient is m. So I will say m is the gradient of the line segment AB, right? And remember, I said for you to have a line, you need 2 points. So for you to determine the gradient, you need those 2 points, right? You cannot if you have one. You need the 2 points. And how would you do it? Here's the equation. It's always y2 minus y1 all over x2 minus x1. This is the same as x1, as y1 minus y2 all over x1 minus x2. So I don't have a preference. These two expressions should give you the same result. So y2 minus y1 over x2 minus x1 is the same as y1 minus y2 over x1 minus x2. It should be. Even if they are negatives, the negatives should cancel somewhere. So this is the expression for the gradient. I hope this is clear. So maybe let's take, for example, AB. I mean, you see there, you have the point y2 there, and you have the point y1, you have the point x2, you have the and these 2 points can be anywhere on the line. They don't have to be at the end of your line segment. This is just a diagram I drew just to demonstrate the concepts that I'll be working with. But these 2 points, which you use to determine the gradient, they can be anywhere on your line. Right? I hope that is clear. Okay. So that's the gradient. It's basically the slope of your surface. I mean, runners would know that it gets more harder to run in an upward slope. And what is causing that is because it's getting more steeper. This m number is increasing. And of course, in a horizontal plane, m is 0. So if you are in a horizontal plane, so the gradient is 0, because I mean it's just flat. There is no slope. Okay, so that's the gradient of a horizontal line. And then there's another concept again with regards to lines and distances that we can define. So this is the gradient. We can also define the midpoint of a line. Midpoint. Can you guys see? So the midpoint M. So let's denote the midpoint. Let's call it M. Of course, it should have an X coordinate and a Y coordinate. And how is it given? So when I say a midpoint, so if I have a line, I'm asking the point halfway that line, right? For example, if you are sitting at Johannesburg, Jozi, and the other person is sitting in Orlando East in Soweto, where I am from, there is a direct straight line between those two, and there should be a midpoint. And the midpoint of a line is given by the halfway points. So x1 plus x2 all over 2, y1 plus y2 all over 2. So this is intuitive. This is self-explanatory. Midpoint, it means it's in the middle, and we take the halves of the sum of the coordinates. Right. And of course, if lines, if points are on the same line, for example, let's say the midpoint in this diagram of ours is somewhere here. Let's say that's M. Right? You see that A, M, and B, they are on the same line, right? This is what we call collinear points. Okay? These points are on the same line, and if they're on the same line, it means their gradient should be the same. And how to express that? You would say then the gradient between A and B, between A and M, which is also the gradient between M and B. So these are collinear points. Huh? Collinear points. So, okay. So what have we done? We have defined and shown an expression and derived an expression for the length of a line, which is also a distance between 2 points, which is that. And what have we done again? We have defined gradient. So this should be 2. So these you should know. This should be at the back of your mind, because you always have to pull them out of your pocket whenever you have to solve problems which are analytical geometry problems. So second is the gradient, and now the third one, which is the midpoint. Right? So we are moving, right? Okay. I hope you are with me. Okay, so I'm going to move right along. Okay. So we move. Let me just remind you of a very basic equation, which I think grade 12 should be able to just remember on top of their head. Since we have defined actually the gradient, the midpoint, we might as well just write the equation of the straight line. So equation of a line, you guys should know it, is given by y is equals to mx plus c, and m is that gradient. So you should have come across this in grade 10, and c is the y-intercept. Okay, so this is just what we can just get out of the way now. This is the equation of the straight line, but we will come back to it. So moving right along, I've just shown you the equation of the straight line. Y is equals to mx plus c. This can also be written as y minus y1 is equals to mx minus x1. So this is still the equation of of the straight line, and you can see that m is the gradient. So if you like, you can say y minus y1 is equals to, what is m? y2 minus y1 all over x2 minus x1, x minus x1. I mean, if you like. But that becomes our fourth equation, which is very important, because I mean, if you have, so what is this equation saying? It's saying if you have one point, x1 and y1, and you have the gradient, then I can give you the equation of that straight line. If you give me one point and give me the gradient, then I can give you the equation of the line. How? This is how. Because here I only demand one unknown point, or one known point, and the gradient. And then I will give you the equation of the line. And when we get to dealing with tangents, to circles, this will come back, because a tangent is a straight line. So this is the equation of a straight line. Okay? So, let's just kill it whilst we here. What if you have so what if you have so this is yx. So if you have a horizontal straight line, so horizontal straight line is something like that's not really a straight line, but it was supposed to be a straight line. The intention is for this to be a straight line. If it's horizontal, then it means y is equals to k, some constant k, because it is horizontal. The x value is always 0, and if you have a vertical line, something like that, this is still a straight line, but with x is equals to k. So constant x, you can see that if this is just a straight line, the x value does not change. So k is supposed to mean constant. So this is a line of constant x, and this is a line of constant y. So those are constant lines, right? So we are just getting this out of the way. And what about parallel lines? What about parallel lines? Right? What can we say about parallel lines? Let me quickly try to get a picture so that we can visualize this. And let's say that is our x-axis, right? So parallel lines, you'll have something like that. It's an angle there. Let's say that's theta 1, and you can have, I hope they look parallel. They do. And you can have theta 2. So these are parallel lines. What can we say about parallel lines from the picture that I tried to draw? And I think it's a very successful picture. These lines really look parallel. So from parallel lines, what we can see about them is that their slant is almost similar, meaning their slopes are the same. So if you take this as line 1 and line 2, so m1 is equals to m2 for parallel lines, and theta 1 is equals to theta 2. The angle which they form with the horizontal axes should be the same, right? So that is just from observation, but of course we can make tests and try to measure these things, but I don't think it's difficult to believe this and just to wrap this around your head. So this is for parallel lines. And okay, what about perpendicular lines? And these are important, because you will get these questions which tells you that this line segment and that line segment are parallel. But what does that mean? They're not giving you that for your amusement. They are giving you that so that you get some information out of it. So if you are told that the two lines are parallel, you know that their gradients should be equal. Right? Okay, let's move right along. Okay, now let's think about perpendicular lines. So let's just take, let's say we have a line segment there, and you have one, and this one forms an angle there, and this one forms an angle with the x-axis there. So this is theta 1, theta 2. So this is line 1, line 2. Right. So we are told these are perpendicular, and it means that the angle they form is 90. And what does this mean? Geometrically or mathematically, it means if two lines are perpendicular, it means they are, when you multiply the product of their product of their gradients should give you -1. So for perpendicular lines, so these are perpendicular, and I think usually in exams or textbooks they like denoting this as something like this or something like this, and this one has always, what am I doing? So this one has always been this perpendicular. This is the sign. So what does it mean? It means the gradient of the first line and the second line must be -1, right? And I will refer you to my trigonometry lessons. Theta 1 can be given as 90 degrees plus theta 2. So you can see, of course, I mean, there you can construct some imaginary perpendicular height, which will make that 90. So beyond that, there is still some angle there. And that angle, theta 2, that angle should be equal to theta 2. So yeah, but it's something that is useful to know. Might not come up a lot, but it's useful for you to know. The important one here, the important results here, it's this one for parallel lines and this one for perpendicular lines. This will be very important when we work with tangents, because a tangent will always be perpendicular to the radius of the circle. Okay? And here you can also define inclination, angle of inclination, which is the angle which is formed by these lines with the positive x-axis. So the positive direction is that direction of the x-axis. So the angle that these lines make with that direction of the x-axis is called the angle of inclination, and is given by, so tan theta, theta will be inclination, and is given by by the gradient. It's given by the gradient. So what is this? So this is inclination. Okay. Yeah. So I mean, if you are observant, you will see that almost all these ideas that I have touched thus far, they shouldn't be new for you, because it's just lines. It's just lines. There's nothing fancy. It's not even second order. It's not even quadratic lines or curves or functions. It's just straight lines. And so this was just a recap, but the hope is that you should be comfortable with these from your previous grades. So now I move from lines now to include circles. So now I go on to circles. Okay, I hope you guys are still following. And yeah, as soon as you see that there is a question that you would like to ask, just drop it on the comments. I would make sure that I read all the comments after the lesson. Just drop it there on the comments, and after the lesson, when I've completed the main idea, then I will look at it and see if I can respond whilst we are still live, or if some of you post questions, maybe I might have to respond later. Okay, but okay, now we're moving along. So now we go to the idea of a circle. So what is a circle? Right? So a circle, So what is a circle? So a circle, this is a set, so I'm giving you a formal definition. In mathematics, we always define the objects that we work with so that there is no ambiguity about what we mean. So a circle is a set of points, points or all points that are equidistant from a given center. They're equidistant from a given center. And I'm not sure whether there are teachers here who are watching, and if there are teachers who are watching, please guys help me out with the relevant language which is supposed to be used so that there is no confusions when it comes to answering questions. As I say, I'm not really familiar with a lot of question papers. I just work with the actual material, so I might not have the information about how questions are phrased and all that. But of course, we are trying. So if there are teachers, please do correct me where you think I'm erring or where you think I'm not using the right language. Okay. Yeah, that's a circle. So it's a set of points. And what do I mean equidistant? So a circle, of course, we all visualize it as something like that. But if you take a given center, maybe, let's say you take a given center, what makes up this round shape? It's points which are all over here. Points. So all these points are of equal distance from the center. So this point there from the center is of equal distance with that one. So joining these points together, then it's what gives you the idea of a circle. So it's just a set of points that are equidistant from a given center, right? And these points from a center, if you consider that distance from the center, it's what we call a radius of a circle. So a radius of a circle is that distance from the center. Right? So this distance from the center to, I think I should say, to circumference. Because that outer part there, that surface, that boundary of the circle is known as the circumference. And you also have an idea of diameter. Okay, or diameter. I don't know which pronunciation you prefer. So what is a diameter? It's a line passing through the center so it must pass through the center of the circle, and it must have two opposite points on the circle. So two requirements or conditions for a line to be a diameter. One, it must pass through the center. Two, it must have 2 points which are on opposite sides of the circle. Okay, so from here, maybe let's just demonstrate this with a diagram. Okay. and we always call the, if if the center is at 0, 0, we call it O, meaning it's at the origin. And let's see, maybe, okay, let me try to draw this circle to scale. Okay, so there I've tried to give it my best. Of course, my artistic skills are horrible. But there we go. Okay, that's not that bad. Okay, so there's a circle there. And you say we define O, and let's define a radius. There's a radius there at a point, let's call that point P. And I think we can also just define Q. I'm just calling that point Q there. Yeah, and from there I'll just say that's X. So this is X. So from there to there is X. And of course, this is a radius because it's that line from the center to the circumference. So it's a radius. So this is a circle, but I've just introduced a right angle triangle, and the hypotenuse of that right angle triangle is the radius, right? And now I can ask you a simple question. I say, in triangle OPQ, what do we have? We have Pythagoras, as always. OP squared, which is R, is should be OQ squared, which is that side, plus PQ squared. So this is our old Madala, Pythagoras, right? But what is OP squared? OP squared is R squared. What is OQ? OQ is X squared. What is PQ? We can define that PQ, I mean, we have a point there, Y, meaning from there to there, it's Y, right? So this is Y squared. And look at what we have there. It's like, yeah, it looks exactly like Pythagoras' theorem, but this time around, this is actually the equation of the circle. It's the same thing though, but I will just explain now what is different. Equation of a circle with center at O, which is 0, 0. The center is there. So in triangle OPQ, we just use Pythagoras, and we could write now the radius as, we could have a proper equation as the sum of the coordinates somehow. So this is an expression, and this is what we call the equation of a circle centered at the origin, 0, 0. Right? So now I can ask you a question and say, what if, let's say the center was at C, which is AB. So let's say, because now the center is at O, which is 0, 0. So now I'm saying, what if the center now is at AB? So this is not 9, this is supposed to be A. Just an arbitrary value, an arbitrary, any number that we don't know. By arbitrary, we mean any number that we can pick. That we are not specific. A and B are just arbitrary variables. Because here, we knew that the center is here, at 0, 0. So what if the center of the circle is not at 0, 0, but at AB? Right? how would this look? Right? So what you would have would be, again, OP squared, right? And here, that point is no longer 0, but now, perhaps I should draw another circle quickly. So now let's circle is somewhere, it's something like this, right? Maybe the center is somewhere there, the point C, which is A, B. So you can still have your radius and R or whatever. But the point is that the center, maybe, let me try it. The center is not, here's 0, the center is at C, not there. Right? So what would this mean for this equation? So what would mean is that OQ, so in this case it won't be OQ anymore, it will be C. So this is C. Let's say there's some Q there still, yeah, and there's some point P there, which is X. It will be, yeah, XY. So what will happen now is that OP squared, it's no longer OP squared, it's CP squared. So let me not confuse you. So CP squared, right, it will be CQ squared plus PQ squared, right? And we know that CQ plus PQ will take away the square root. So CP square. Now, CQ squared now, it's the distance between Q, right? And you see that P and Q are on the same X value. So you can say that is X, the value there is X, minus the value of X at C. So the value of X at Q is X, but the value of X at C now is no longer 0, but A. So this is X minus A all squared, because we want the distance between C and Q. But C is no longer 0, it's A. So we have to say the X value at Q minus the X value at C for us to get that distance. And the same goes for the Y values. So the Y values, it will be Y minus B all squared. And we know what CP is R. So R, or if you like, R squared is X minus A squared plus Y minus B squared. So now, so now, look at that now. From this to that. Can you see the difference? The difference is that here the center, so maybe I should say center C at AB. Here the center is at AB. So in this expression, if you always get something like X minus a number, Y minus a number, you must know that those are the coordinates of the center. Those are the coordinates of the center. So here you can see that it's as if you have X squared minus 0 so X squared minus 0, or you could have X minus 0 all squared plus Y minus 0 all squared, which is ultimately X squared plus Y squared. So here the center is at 0, 0. There's the center, 0, 0. But here the center is at A and B. That's very important. I hope that makes sense to you. So now, the last concept, just still in this page, which I want us to consider concept of circles is what we call a tangent to a circle. So a circle can have a tangent, and by a tangent we mean a straight line which touches the circle at only one point. So if you have a straight line there, and it will touch your circle somewhere there. So T, this is a tangent, and one property of tangents is that they are perpendicular to the radius. So a radius is any line from the center to the circumference in this circle. So we can construct another radius there. And what we know about tangents is that they are perpendicular to the radius of the center. So this is a tangent. And what does it mean? A tangent, it means the gradient of the radius multiplied by the gradient of the tangent must be -1. Why? Because we spoke about perpendicular lines earlier. We said perpendicular lines, the property that they have is that if you multiply their gradients, they give you a -1. So that's the product of the gradients of perpendicular lines. So a tangent is perpendicular, always perpendicular to a radius. And that means that the product, by product, I mean the multiplication between the gradients is -1. Right? So I'm not sure whether any of the concepts that I've discussed thus far are clear. I hope they are. There is nothing difficult thus far here, actually. You just need to have the guts and the courage to deal with laborious equations like this. But as soon as you write them down, they are clear. So there is nothing that should be difficult here. But anyway, now let's take examples so that we try to hammer in these concepts. So let's take a few examples. So I'm not sure whether you guys can still see. Please do comment whether you can see what we're doing or not. Clearly I must not only invest in technology, I must invest in someone that can set this up and be able to make sure that these videos go smooth moving forward. But anyway, let's move with what we have. So here's an example. So you're given a circle with center O, and when they give you a center O is usually origin. O is usually denotes origin, meaning x is 0, y is 0, and you're given 2 points P and Q. And P is a point -5 and 5. Okay, so I'm going to take this one because it's the organizers. Hi guys. Hello? Okay. All right. Okay, sorry about that. And I'm sure you could hear the way that the phone even rings, that it should be a Nokia 3310 or something. I don't expect grade 12s to know what a Nokia 3310 is, but it's a legendary phone. Yeah? Okay, so here's a problem. You are given a circle with a centered origin and 2 points, which is P and Q, -5 and 5. So because these are problems, I will just draw this, draw the circle roughly. That went too wrong. Okay, and you should have some circle, and the center is supposed to be at the origin. Okay, so excuse my drawing again. Okay, so let's just say O. Right? So the first question is plot the points on a rough sketch. Right? Plot the points on a rough sketch. So P is the point -5 and 5. X is -5, Y is 5. So P, if we had drawn this according to scale, it was supposed to be a point somewhere there. -5. Wait. -5 is this side, actually. supposed to be somewhere there. Minus 5 and 5. So this is P. Okay. And then Q is 5 and minus 5. So X is 5. Y is minus 5. So Y is minus 5. This side of the Cartesian coordinate. And X is negative this side. Negative this side, positive this side. So positive 5 should be somewhere there on this side, but negative 5 should be somewhere there. So this Q 5 and minus 5. Right. So this is just a simple exercise. Draw the graphs, draw the points, just show the points, and of course there'll always be a radius, but we're not there yet. So the second question, determine the equation of a circle. Determine the equation of a circle. In just the previous rough page we had, we derived the equation of a circle. And what is the equation of a circle? When we derived it, we said the equation of a circle with the center at the origin is r squared, which is x squared plus y squared. And I said you can picture this as something like x minus 0 all squared plus y minus 0 all squared. So this is the equation of the circle centered at the origin, right? And here we are already told that the circle is centered at O at the origin, right? So we move on. We know that this should be r squared, right? So choose like any point. So if we take the point P, x there is minus 5, so this is 5 all squared, plus y is also 5, so 5 squared, and 5 squared is 25, plus another 5 squared is 50, so this is 50. So this will imply that r, typically, I mean, the way you would write it, you would say it's plus minus the square root of 50, because indeed, r squared, because it's a square, it must have two roots. But here we know that we are speaking about a radius, distances. So a radius is a distance. So we don't speak about, I mean, you never say, for example, I mean, of course, I'll give you an example of where I'm from in Soweto. You don't say, I walked from Orlando to Maponya, negative 4 kilometers. I mean, distances are always given in positive values, unless you specify. If you want to give a different direction, you specify that no, it was 4 kilometers from Orlando to Maponya, or from Maponya to Orlando. So that's the point I'm making here, that since this is a radius, we don't have to consider a negative, so we consider the positive root, and so r is the root of 50. So this is the equation of the circle, of this circle. And even if you had taken the point Q, which is 5 minus 5, you would still get this expression, because, I mean, the numbers are the same. Negatives don't make a difference because we square them, and the square of a negative is a positive. Okay? I hope that is clear. So this was the question, determine the equation of a circle. So let's go to 3. Okay, so 3, it says calculate the length of PQ. So now we must, calculate the length of a line segment. And remember what I said earlier. On the very first page, I said this, which we had done earlier, was deriving the equation of the line segment, the length of the line segment, distance between 2 points given by this expression. So it's coming back now. So how would we do that, right? So we know, so it's PQ. So where is PQ? line segment PQ. So if P is there, maybe it might be that line segment there. I'm not drawing it properly, but my thinking is that actually it should pass through the center, but I will tell you why. But just the line segment PQ, and let's go on with the problem. And PQ, you have 2 points. We know that the length of a line segment PQ should be given by x2 minus a, or x1 squared, plus y2 minus y1 squared. So this is like b. You can replace x1 and a and b by x1 and y1. And then, but we know, so I mean, x2 and y2, these are values of x and values of y, either at q or p. You decide, as long as you will make the other point. So we know that the numbers here are 5s. So this would be x2. So let's take q as our 2. So we'll take this as 2 and p as 1. So x2 is 5 because it's q, minus x1. But it's minus x1 because it's minus 5. So there will be 2 negatives, which will give us a positive squared, plus y2. Y2 is minus 5. Minus y1, so this will be minus 5 squared, which still minus 5 minus 5 minus 25. This still brings us to the root of 5 plus 5 squared. So 5 plus 5 is 25 squared. 25 squared. Plus 25 squared, I think ultimately here we'll get the root of 200. You can check that. But this is a simple calculation. It's a simple, straightforward calculation just by applying the equation of a line segment. This equation that you must know. And I think in your exams or test is provided in a formula sheet. But there is no harm in knowing this equation. It's not a difficult equation. Okay? So now, so 4, what does 4 say? 4 says, explain why PQ is a diameter. Why PQ is a diameter. So, now you will understand why I gave you these definitions. A diameter is a line passing through the center which has 2 opposite points on the circle. So let's look at what we have. So 2 conditions. Does this line pass through the center? Remember that I did not draw it to scale. But the first thing we can see is that the point P and Q are opposites. Because you can see it's minus 5. This side is 5. 5 minus 5. You understand? But we can also show that this line segment passes on the origin. You can just consider the gradient from O to P and the gradient from O to Q, and I think this should be similar. There should be 1. I think I think MPO should be equals to OQ, which is 1, because these are 5s. Because this is 0. So that's why this is a diameter. Why? The points are passing through the center and they are on opposite ends. How do you show they are passing through the center? You show that if you take the center as the point 0, 0, and you calculate the gradient between there and there, OQ, and then there, these two will be equal, meaning these points are collinear, meaning it has to pass through the origin. Okay. All right. So let's move. I'm not sure whether this is a bit clear to you. And as I say, I have that leeway that if something was not clear, or if you have a question now, just drop it and I will look at it maybe after the main lesson or even later. So we move on. So what's the explanation of this being a diameter? points P and Q are opposites, and that line segment PQ passes through O, the center origin. Okay? I hope you guys are following. Okay, we move on. Let's take a second example. So what we were trying to demonstrate with this example, we were trying to just hammer in that Pythagorean relation, because it is Pythagorean. So when you look at it, you can think, this is Pythagoras, but just to hammer in that this is an equation of a circle centered at the origin, and also to hammer in the concept of the length of the line segment or the distance between 2 points. I hope those are clear, right? Okay. So, second example. So you are told that you are given a circle with center at the origin again, and the radius r is the root of 45. So the question is, what are coordinates of points in a circle which have a x value that is twice the y value? Okay, so this is where mathematics sometimes gets tricky in the English, especially for those of us who are not primary English speakers. Maybe to try to get around that, try read the question 2 times or 3 times so that you make sure you hear what it's saying. So let's read it again. It's saying you're given a circle with a center at the origin, and the radius is r, the root of 45. So they're asking, what are coordinates of points? So there are points in this circle which have an x value that is twice the y value. Okay, so how can we proceed? We start by what we know, famous golden rule of mathematics. You use the knowns to get the unknowns. What do we know? We know the equation of a circle. It must be x squared plus y squared. So that is what we know, and we know that the radius r is given by root 45. So we can just substitute the radius here. So it will be 45, because if you have a square root and you square the square root, it removes the root, and that is x squared plus y squared. And the question is, which values of what are coordinates of points in a circle which have an x value which is twice the y value? What is twice the y value? So we want x values which are 2y. Twice is 2 times y. So we will substitute x here for 2 times y, because we are looking for y values which are twice an x value. So this is 45, which is 2y all squared, right? Plus y squared. And this is 4y squared plus y squared. So this should be 5y squared. So y should be 45 y squared should be 45 over 5. 45 over 5 should be 9, meaning y is plus minus 3. Okay? So 2 values of y. And here we don't have a problem with a negative number, because this is not a distance. This is not a radius. A radius, we know it's a distance. Here, these are coordinate values. These are y values. So to get the corresponding x values, what we need to do is to substitute in the equation that we have these values of y, and then find the corresponding x values. and you are grade 12, so I'm not going to just do that easy one for you. I'm sure you can do it. I mean, if you substitute, remember you had 45 is equals to x squared plus, if y, so what's y? If y is 3, so this is y squared. If y is 3, even when y is minus 3, because it's a square, it will be 9. Meaning x squared is 45 minus 9. 45 minus 9 is 36. So this means that x is plus minus 6, because the square root of 36, the square root of 36 is 6. So the point, so these coordinates where the x value is twice the y value, is the point where you have, if y is 3, substituting it here, so you'll have 3 minus 3 minus 3. No, the x value is 6, so it's 6 3 minus 6 minus 3. So these are the two values where x, these are the two coordinates where x is twice the value of y. And you can see 6 is 2 times 3, minus 6 is 2 times minus 3. So we have found these coordinates. So here are these coordinates. Okay. I hope this is clear. And remember to post a question or a comment if you think something is new and makes more sense. Just give me that feedback. So now we're going to the third question. So what we were trying to do here is just manipulations. You will get these questions. The previous time you were given 2 points, not given a radius, told to find the equation of a circle. Now you are given a point, 1 point, which is the center, and you're given a radius. You see, they can give you any of the variables. You just need to know how to move from that variable to what is needed. So just hold on. This is the second last question. After this one, we deal with the last question and we are done for the day. All right. Plus, we even started the lesson late. So the third question here, which is an example again, says, determine the equation of a tangent to a circle with this equation. The equation is x squared plus y squared minus 2y plus 6x minus 7 is 0. Right? So they say determine the equation of a tangent. So there is a circle which has this equation. And remember, you are told this is an equation of a circle. And an equation of a circle with center at the origin is that one, r squared, x squared plus y squared. It means this one, the center is not at the origin. Okay? But I will show you. So they say of a tangent, here's the equation of the circle, and you are given a point f, which is minus 2 and 5. So the first thing maybe that you would want to know is that just get this equation to be in the form that you know. The form that we know is something like r squared is x minus x2 minus x1 all squared plus y2 minus y1 all squared. Or something like x minus a all squared plus y minus b all squared. So this is a standard equation of a circle. This is how we write it in standard form. So here it's not in standard form. We need to put in some work so that we can put it in standard form. And just by looking at this equation, maybe let's start rearranging. Group the x's and the y's, we call them the like terms. So x squared plus 6x plus y squared minus 2y is equals to 7. Just take 7 to the other side because we want a number on the right hand side. And here then we can use a strategy I learned in grade 10 called completing the square. If you forgot it, please revise it. It might come in handy. Completing the square. And why am I completing the square? It's because I want to write this equation in this format. So what do? I can see that what can at least that's why I'm saying go revise this. I'm not going to teach you again how to complete the square, as I said, it's grade 10 syllabus, but just go revise it. But I mean, just from observation, you can see that what would make x squared plus 6x a perfect square is if there is 9 there, because x plus 3 squared can give you that expression. So x squared plus 6x plus 9 minus 9, the number that we add we also minus, because we don't want to interfere to lose the generality of the equation. So this is just the same as adding 0. We've added nothing, basically. And now we move to the y's. Y squared minus 2y. And which number, if we add here, will give us a complete square? Can think about 1 plus 1 minus 1 equals to 7. Because here we add 1 minus 1, which is 0. So we've added nothing again. But this is a strategy. This is a strategy to solve these equations and to get this equation in standard form. So we are using completing the square now. And we can factorize when we are there. This is x plus 3 all squared, right? Plus, we can factorize that one. Should be y minus 1 all squared equals to minus 9 minus 1 is minus 10, because we'll add the 9 and the negative 9 and the negative 1 is minus 10, and you transpose it to the other side, it will be 17. So you can see that now you have it in standard format. Now you have it as x plus a number squared, as we have it there, plus y a number squared is equals to some number, which is a radius. Now we have it in standard format, and you can see that the center here is at minus 3 and 1. The center is not at positive 3, because remember, this will be a root. This means x is minus 3. If you say x plus 3 is 0, this would mean x is minus 3. Y minus 1 is 0, y is 1. So the point here is 1, not minus 1, but 1 and minus 3. So this is the center of this. So we've moved from this equation to this equation, which is in standard format, which is now giving us the equation of this circle, but also exposing its center, which is not clear when you look at that expression. Right? And let's get back. What was the question? The question is determine the equation of a tangent to the circle with this equation. Okay, so we want the equation of a tangent, but we know that a tangent is always perpendicular to the radius, right? The gradient of the tangent is perpendicular to the gradient of the radius, right? So with that information, then we have the radius here. So this is r squared, meaning r is equals to the square root of 17. Right? From this equation, this is r squared, meaning r is the square root of 17. Right? So r is just the root of 17 units. So anyway, now we have the radius. Now, what can we do? We are given a point which is f minus 2 and 5, which is a point on a circle. So this is where we must determine, so this tangent is tangent at this point. So we had a circle, this tangent is somewhere there, and that point is minus 2 and 5. And there must be a radius somewhere there. Right? So what do we do now? We want to calculate the gradient of the radius. Why? Because the gradient of the radius, if we multiply it by the gradient of the tangent, it should give us minus 1. Right? So, meaning we can get the gradient of the tangent if we have the gradient of the radius. Okay? So, gradient of the radius, I call it MR. So, it's y2 minus y1 all over x2 minus x1. Which points do you have? You have 2 points. You have the point F, which is minus 2 and 5, and you have the point C, which is minus 3 and 1 already, the center. So it's as if it's that point C there. So what's y2? You can choose any. So if you choose y2 to be F, this will be 5 minus 1 all over minus 2 plus 3, which gives us 4. So the gradient of the radius is 4. But we know that the gradient of the radius multiplied by the gradient of the tangent should give us minus 1. So this implies that the gradient of the tangent should be minus 1 over 4. Right? Now we have a gradient, we have a point f. This is f. We have a gradient, we have a point f, and we have the equation y minus y1. So you see why these equations are important now, because they keep on coming up. Yeah, so where did we have it? So remember this equation, y minus y1 is mx minus x1. So now it's coming back. It's coming back here. Y minus y1 is mx minus x1. So we have a point which is f, right? Minus 2 and 5, but we've just calculated our gradient now from using the gradient of the radius. So basically now we have the equation of this tangent. And we can write y, what's y1? If we're dealing with the point f minus 2 and 5. So this is minus 5 is equals to minus 1 over 4 x minus 2, so it should be x plus 2. So I'm going to write the equation here finally. So finally the equation should give you something like minus 1 over 4x plus 4 over 2. 4 over 2. Just check that, because you'll have actually I think it's 5 over 2, because you'll have 2 over 4, it's minus 1 over 2. Yes, minus 1 over 2, and then 5. So it's 4 and a half basically. 4 and a half. I think it's 4 and 1 and a half. So you can just check that. But yeah, that will be the equation of the tangent. So look from where did we move? We moved from having an original expression which is given to us, which is an equation of a circle. But this equation of a circle is not in a standard form. So we need to write it in a standard format for us to be able to get out the center from it, to get a point and the radius. We've done that, we got the radius and we got the center. And when we have the radius and the center, we use the center and the point where we need to calculate the tangent of the equation to calculate the gradient of the radius, because now we have 2 points. You have your center and you have your f. You get the gradient of the radius. You know that it must be equals to minus 1 if it's multiplied by the gradient of the tangent, and that's how you get the gradient of the tangent. And then you have your equation. You have everything you need now to write the final answer, the final equation. So this is I think it's been some time. I think maybe let me take it up until this far today, but I had wanted to go on to another example which is more involved, which has midpoints, which has intersecting tangents, which is also again hammering the fact of the idea of perpendicular lines, straight lines, circles with a particular center. So you can just, I'm not sure whether the camera is able to show the question clearly, but I would appreciate that maybe you try this one, maybe as your exercise. With what we've done, with the examples we've done, you should have enough skills now to tackle this exercise. And again, once again, I want to encourage you that if you are a learner that is doing mathematics, you will not succeed if you do not do your work. So laziness will not work. You need to do a lot of questions, a lot of exercises to give yourself that advantage. so that even if a question is difficult, but at least you can get something out of it because you've seen it before. So, and you cannot learn maths by looking and by listening. So you've been looking at what I'm doing and listening to what I'm doing. You need to go do it yourself. And I pray that you will have all the strength, all the energy during this difficult time to stay safe, but still doing what is expected from you. Thank you for giving me your attention, and I'm not going to stop the live video. I'm just going to check if there are questions which I need to respond to. So I'm just going to check. Perhaps. So just give me a moment. I just want to check if there is anyone who has posted a question. Yeah, but I think for today, I think that is enough for today. We have covered the important aspects of analytical geometry, and this should be it. With these skills, if you can just polish these concepts, there should be. So I can't see anything. I'm not sure whether, guys, you have there's a question. I can't see any question thus far. So yeah, okay, guys, I see that there are no questions. It means I was crystal clear, loud and clear. So I'm glad if mathematics can be received like that. Take this from me. This is very easy, right? You just need to sit down and do your work. And again, God bless you. Stay safe. This is from your personal tutor, Cozy Mentor. Amen.